All right, now record. Okay. All right, 3D printing. Has anyone here 3D printed before? 1, 2, 3, 4. All right. So let's talk about what 3D printing is. Let's talk about what is. Oops, wrong one. In a moment. Okay. So what is 3D printing? So there's different types of 3D printing out there. There is FDM, which is 3D deposition modeling, which is what we do mostly here, which is that layer by layer that most people see. There's also, so it's like additive manufacturing. There's also SLA printing, which people have known as the resin printing. You guys have seen those liquid that use the UV light to kind of solidify into a part. All right, so these projects. Sorry, it's been a long day, so bear with me real quick. Okay. But yeah, they're pretty simple to make. They're pretty affordable. Most printers like this, so here is about $100 to $300 to afford, and you can make basically almost anything. I wish I had samples, but today I unfortunately didn't have time to get samples from my house. So yeah, but because of the layer by layer and the precision required from these machines, it does take a long time. Most prints that you would think would take only a few minutes, but actually, or maybe an hour, would take about a day or so. So yeah, it's like this mouse right here. There are files for similar mouse, and they would probably take about 5 hours to 7, depending on your print settings, the type of filament you're using, and the type of printer you're using. So it all varies with different printers. So kind of materials are out there. There's many to choose from depending on exactly what you want from what you're applying it for. So for instance, most people like this right here, this filament right here is called PLA, or you can see it's like a type of biodegradable material. It's actually corn-based. It's biodegradable because it is corn-based.
It's biodegradable in very specific settings.
Yeah.
And environments.
But it's affordable is what matters more. And it's because if you guys ever use a soldering iron and put it to this plastic, you will smell the sweet smell of cancerous corn, as I have done that in the first floor of the engineering building. It's not fun, but yeah. There's also ABS, which most plastics that you see around that are injection molded, or the normal way that most people, like let's say this chair right here, this is probably injection molded. So they use a type of filament or plastic called ABS. That's usually cancerous to use. That's why they have the proper industrial area settings to use. You can 3D print them, but you should, put it in a nice ventilated area.
Actually, there's a kind of very common misconception with like PLA and ABS.
Yeah.
So the interesting thing is that PLA emissions are actually more toxic than ABS emissions. PLA just emits much less than ABS.
Oh, well, that I did not know. But dang. So they both are toxic.
Yeah.
In general, though, when you want to print, do not put your printer next to your bed. Don't sleep with it. Like, it's not a good idea in general. But any of the filaments, no matter what you do. If you're heating up plastics to a high heat level, you're gonna have some like VOCs. So you want to make sure it's in a separate setting, but be extra cautious with PLA and ABS. ABS more so because it's more, but like still you don't want to breathe that in like constantly.
Actually, something that's very article on like 3D printing emissions.
Good thing, because I've been sniffing it don't even talk about it. Anyways, PEG G. So PEG G is a type of flexible. Yes. So if I have that thing in my kitchen, I should not use it.
No, don't do that.
Put it in a different room. I suggest a very highly ventilated room that no one usually goes into and lives.
I like the garage.
Perfect.
Yeah.
I think they should be ventilated because your car's exhaust has to go somewhere in the garage. So it's probably ventilated because you do have those little cutouts in the roof. So that's fine. Just don't put it next. Don't sleep with like our previous president. He had multiple printers in his bedroom. Not a good time. Don't do that. Anyways, back to PETG though. That is basically a nice flexible material. Not too flexible, but so it's just enough, but it can depending on what kind of stresses you're going through, right? Do you want something that's like able to withstand a lot of stress, but then you'll shatter, or do you want something to like slowly like bend away and then break eventually? Like what kind of are you looking for like a more like instantaneous rigidity or like a overall? It just depends on like what kind you want from your piece. For PETG, it's mostly for like flexible things, like you want to be able to like kind of bend it out of shape slightly for a little bit and bring it back in. But in a way, it is less durable than PLA, but PLA is really brittle, which is the problem. Also has very low print temperatures. The PLA being affordable, it's highly brittle. You can actually snap it open, and also it has low print temperatures, so that in the sun things will like melt really fast. So we've had that happen with our other project actually. So be careful with like even again, what are your parameters for your design? What do you want it to use? Right? If you're okay with like if your operating temperatures are like within like the usual range of like 70 degrees like Fahrenheit, 80 maybe on a like hot day, PLA is fine. It can go up to like 100, I think, maybe 90. But then if it's in your car, that's gonna like nicely toast it up. All right, TPU is also flexible like PETG, but it's more used for like rubber feet, rubber wheels, trying to get that grip, and also it's a little bit of padding in the suspension. And nylon is also similar to PETG in a way, but it's a little bit more harder. And PVA is your SLA print, so not PVA print. PVA is like water soluble filament used for supports most of the time. So you can just put in water and it'll kind of dissolve away. And then you have composites, like types of filament that like have like metal in them. It's like PLA, but like you can have metal shavings in it, kind of, or have carbon fiber within it. But it's not actually carbon fiber, it's still plastic, but has some extra durability with it. So just, again, depends on your operating stuff. Yes.
So all these you can use on the same printer and work for.
That depends on your printer too. What kind of temperatures can your printer go up to? What kind of capabilities does your printer have? For instance, a lot of these prints right here. So PLA, you can print anything. Right? Any printer can usually go up to temperatures because its print temperatures are around 200 degrees Celsius for the nozzle. You don't have to have a heated bed, so anything can usually print that. Then you get ABS. You need 110 or 100 or 110 degrees Celsius for the bed for it to actually stick to the bed. And then the temperature I think for the nozzle is like 230 or something like that. It's been a while. PETG is also similar, 220 or so. But I think 75 or something like that for the bed. For PETG and TPU especially because it's really flexible. With this Bowden, so this is called a Bowden tube right here, right? So what you have is a lot of back pressure from the extruder going up and causing it to like go in, right? For TPU, this because it's really flexible, it actually won't give you a proper like a constant flow because of how bendy it is, like how it's basically like a compressible solid, which is not possible, but yeah. So you'd want actually a direct drive. So you'd put the extruder into the back like this on the actual extruder head. That way it's a more constant, like there's less pressure, like variance per unit of the material. If that makes sense. Yeah. Okay. All right, safety. Let's talk about safety. And oops. Okay. Look at that. Number one, well ventilated. Let's keep those noses safe, guys. Keep those lungs plastic free, please. And also make sure you don't touch the nozzle. Nozzle's over here. If you touch it, you will burn yourself. You will not be happy. That can go pretty high. This can hit about 110 degrees Celsius, so over the boiling point of water. You can cook on this kind of. I've cooked a Pop-Tart on this thing, so again, I have videos to prove it. Okay, look, it's just a heat plate, guys. You can do that.
With plastic residue on it.
That was because I put a plastic plate, but that was their idea. The second time I did it with aluminum foil, see, that one was safe. Okay, guys, that was safe. It tasted like a Pop-Tart. Not well toasted, but not well toasted. You know what I mean? Like
It's like plastic.
well, because I had a plastic plate under it, and then that kind of all the paint. Okay, anyways, yeah, and then the parents have moving parts, so you can see you have moving. Actually, let's take out the gantry plates to show you the internals of the printer. Give me a quick second, because I gotta unbolt the screws. It's two screws. But let's talk about the moving parts.
Is the article good in the chat?
So let's talk about the moving parts here. So you have your your XY motor right here, or X motor right here, and you have this belt, and you have the the actual shoot, I put a name for these. Oh no. My mind's thinking, yeah. So you have these bearings, and then so we call them this rails. Thank you. Rails. Sorry guys. Anyways, so these can move pretty fast depending on the printer and what it's doing. So don't want to put your hand while it's doing it, especially when it's low and your hand will get stuck and you'll not be happy. Again, be careful about all the moving parts and the plastics. All right. You also want to make sure you have part clothing depending on again, you have moving parts with motors, so they can wind up into the actual belt sometimes, or even the motor. So no loose clothing. Make sure if it does fall on you, it has fallen on me. So again, be careful. Wear some shoes. It'd be nice, but as long as you know what you're doing, in terms of shoes wise, you should be fine. And then again, fumes, guys, keep those lungs safe. Cannot iterate that enough. All that. All right. So for calibration, that's one of the key parts for 3D printing is getting this calibration right. If this is wrong, your entire print is a failure. All right. So this first level matters the most, and it's the most crucial. 99% of the problems that occur from 3D printing occur at this first layer. So you gotta make sure that the nozzle is close to the bed. Most printers will say that they want a 1 millimeter clearance between the nozzle, so that little pointy thing is underneath this. I don't know if you can see it right here, and the bed, right? You can use a piece of paper to kind of measure because about 1 millimeter thickness. You can use a dollar bill, so we use in high school to kind of feel because it's a little more gritty. You can also eyeball it, it's what I do. So we'll do a bit that more hands-on later on as the lab part of this lecture goes. But basically, when you calibrate the bed, you also want to heat up the bed and the nozzle, because when things get hot, they expand. So that can change the tolerance of your between the nozzle and the bed, right? So if you calibrate with a cold nozzle and cold bed, you heat it up, all of a sudden that 1 millimeter gap becomes 0.02, I don't know. But yeah, so that's happened before as well to other people when I'm teaching them. Did a cold, called a cold calibration, and then they heat it up for the actual part, and the bed becomes way too hot, and then you have problems. So you gotta make sure you calculate basically the four or five points in your left, right, and back, left, right, in your center to kind of average it out. You can do multiple, one of that if you want to. This depends on your printer, or if you can use disabled for motor drivers, then do it yourself manually. Some printers also have automatic thread leveling. So Ender or Calibration has VL Touch. And then I don't know if the other ones are called for all over the other printers, but they can kind of basically probe the bed and just figure out the distance that way. I don't like using that much, mostly because I'm used to doing it with my hands. But I know once you get good with the automatic ones, you just let your printer go by itself. But for these entry level, $100, $300 range, you won't really get the bed probing. So you gotta do it manually. So they gotta be more integrated, into more, sorry, shoot. You gotta be more hands-on with it. So Okay. So there's many like types of tests you can do also with your printer to make sure it's, the color is good, your other settings are really good too. So there's the Benchy, it's up there. You have a mill cube, 20 by 20 by 20 millimeter cube you can use, also online. There's other stuff like CaliCat, it's up there, and then you have the torture toaster. So again, all to test different parts of, or different ways that your print can print. This will give you basically the tolerances of your printer and what its capabilities are. So you can use that to your advantage on changing different settings to see if you can push it more, or knowing that like you can definitely do a certain amount of overhang or just amount of tolerance or clearance. So you can design parts specifically for your printer to print optimally. So certain prints won't print at your printer because your printer just can't do it. This is a good like kind of tester for it. All right, troubleshooting. It's kind of also important is to see when things go wrong, what to do. How do you recover from things going wrong so you can do it right? First one is always the first layer. Actually, all of these things most happen in the first layer. So if your first layer is kind of messed up, you got to make sure your calibration is proper, right? It's not too far away where basically you're having a bead of filament. You don't want to bead a filament. You also don't want a flat like line of filament that's engraved into your bed. You want a what's called a flat ribbon. So we'll go over that again when you go into the lab and see exactly what I'm talking about. This elephant split, which happens when your bed is again too high, or it's high enough or low enough where it can create the flat ribbon, but it's still on the higher side. So that'll cause the bottom of the first layer to be a lot more thicker than the rest, and you'll kind of see like a little extrusion. And then the warping is what happens over here, because materials tend to shrink. So you gotta compensate for that. So that means that either your bed leveling is a bit too low, or you might need a different way to combat this by going to your slicer and changing what's called the skirt or brim. So depending on if you're warping or not and how big your part is, we'll go through that as well. How do you get your parts ready to slice as well? Yeah. And if it's fused to the actual print bed, you can't take it off. You're way too close to the bed. So basically engraved into the bed, the first layer. All right. For stuff like this, for filament issues, this are all like mostly splicing settings in this case. So your printer is set up wrong on your actual slicer. If it's stringing, you gotta make sure your tactics are okay. So we'll go over all the settings that you can change on the slicer. We'll talk about all this. So like you gotta make sure your throats are right so you don't get any over or under extrusion, which can cause like gaps or holes in your top layer and whatnot. And then if your filament is breaking, you just gotta get like your filament could be it could absorb too much water. So PLA has a tendency to absorb water. When you absorb water, it becomes more brittle and it'll snap and it'll break pretty easily compared to when it isn't. So you gotta make sure your filament's in the right conditions as well. Right. So print shifting is a common reoccurrence depending on a lot of factors. So the first, again, is bed adhesion, right? If your first layer is bad, your first layer can lift off the bed, and the next thing you know, your entire print is shifting according to your nozzle, because it's sticking to your nozzle. So as your nozzle is moving around trying to do apart, your entire print is going with it. And then you get these random shifts, or even it's just a stringing or like purple. And it could also be a harder problem where the belts start slipping. So what could happen is that sometimes that the significant an inefficiency in your top layer, or when it's printing, like a little tiny bead of filament is like usually like it would leak out somewhere. It'll get stuck to the nozzle, it'll harden somewhere on the top layer. And then when the nozzle goes over it, so it's a hard layer, it'll kind of the whole belt will slip, keeping the nozzle in place, and that'll kind of reset the whatever its position is, shift it, if that makes sense. So basically like it wants to go one way and you hit it, and now the belt will think you're going somewhere else, but your thing is still there. So use that reference point, and next thing you know, your reference point's wrong. Right, and that's what it gets. Same thing with lubricants and drive coupler, all of this basically changing the reference point of what it was versus what it is. All right. salmon skin is basically like this, kind of scaly. Where what happens that like sometimes it could be that the vibrations of your printer, if it's on a wobbly table, it could cause a little vibration, like a little oscillation in your bed, and that could cause this to happen where it could basically it's more little elephant's feet in a way you could say per layer. You gotta make sure like all those steps like combing and then Z-stepping, which is again all slicing stuff you can do. Most often you reduce the flow and increase your traction. It's like for your first two steps. Reducing the flow would be like, less filament is gonna go in per unit smoothing. That could help with reducing the excess filament, basically your salmon skin. Or it could be that your retraction resistance is not high enough. All right, slicing. So slicing is basically you're getting a part. Let's say I want to print this piece, right? The printer can't print this in one go. It's not injection molded, right? It has to cut it up into slices and go layer by layer up. That's what this is, slicing. Your slicing software determines like exactly how fast your print's going to be done and how the quality is going to be, what other settings are there, check supports or anything else. It's all decided in the slicing software before it turns into G code, which is what your printer reads. So there's stuff like infill, which is how much stuff is in the actual part, how dense it is. Depending on how you want the part, right? Depending on your use case, you'd want different infill. Usually you'd want a 15 to 20% infill. That's because that's the best like price per unit weight structure, right? So anything more than 20%, you want a really strong structure for something like maybe something that's undergoing compression or tension. Mostly compression, because they probably can't do tension. And then if you have too low of a limit, like 15 or 10%, that's for really weak parts, like if you just want like a desk sculpture. Then you do like 10, 15%. Because you want to save on price, you want to save on time. Because 30% or 50% will take days to print even. And they'll use so much filament, you'll probably run the entire roll out. And then if you're not going to use it for something strong where it doesn't even need to be that much like that dense, what's the point of wasting all this time and money into it, right? So 50-20% is like your gold area. Like that is your best price to performance type. Support is for making sure that your overhangs are supported. It can't print stuff out of thin air. Now, depending on a printer, you can technically do it. It's called bridging, but you still need to have some support, some structure to start and finish it. But your quality will be lacking depending on that. So these are the 3 supports that are in Cura you can use to help with that with overhangs. Sometimes you'll find out that you won't need supports, even though you think you might need supports, depending on the type of material you're having your printer as well. Like for instance, PLA is really good at certain distances for bridging, but ABS might not be, and you might need supports for that for the same distance. So it all depends. And then your temperature can also depend on the material that you're using, also on your custom settings on how you run your printer. Your bed temperature, your nozzle temperature, what layer should turn what temperature. It can always be decided in this G code. And your speed, that's for your $100, $200 printers. There's a lot more printers nowadays that can go way faster than this. But for your entry-level printers, you can get 50 millimeters per second, which is your usual average for most materials. This can vary, it can go down or up depending on your material. Because some things don't like to flow as fast. You gotta be a little slower, gotta be more careful. Like for flexible filaments like PETG or TPU, you might want it slower or faster because it tends to be really stringy because it's really flexible. And then your travel speed and how fast your printer will travel without having a print there. You have your print orientation, which is how you want to print, because that will change how long your print's going to be made. You see this right here, it's hollow in the inside, right? But it has a base. So you'd want to print, and it also has curves on the outside. So how would you print this? Because it goes layer by layer, how would you print this? Okay, so you would print this vertically, or you try to optimize for vertical. Because there's overhangs you don't want to deal with, the supports, you can't even get all the way into there with your pliers, right? You want to reduce the amount of bridge or supports you want in there. There's also, these two might be flat, but you have the overhang a little bit. Versus a nice flat face. You want the nice flat face.
What if your GB printer can't go that high? So what would you just do?
So your printer is smaller than this.
Okay,
Okay, if that's the case, but it's wide enough for this,
yeah, so.
Okay. then you probably have to do it like this and see if you can do it without supports. Or you get a dual extrusion printer and you print the supports in the soluble PVA filament, dunk it in water, and lose supports. Again, it depends. Also, you wouldn't want to print it on the side. Or let's see, the print area of this, the first layer area of this versus the first layer area of this, what seems more promising? This small little area here, this thin rectangle, or this thicker rectangle, or not rectangle, but so that depends because you want a nice big enough area for the print to stick well to. So your first layer is nice and a good foundation. You want a good foundation. With all these overhangs, you won't really have a good strong foundation, and that will result in a bad print. You'll get print shifts, and your print's gonna mess up. So try to find a nice flat base to use as flat as possible for most prints. And what will seem optimal with the least amount of supports. Especially, this has like the worst side to use because there's nothing inside, so you have a really, really thin print area. And you don't want to do that. And so the thickness of the walls, that's just the thickness. So if you see on this print here, you have infill in the inside, right? You have these solid lines that go around the perimeter, that's your walls. So that depending on how many layers of walls you have, that'll decide how strong your part is. You could actually, if you find a nice balance between infill and wall thickness, that'll be your most structurally stable part. Because you have a nice amount of walls for withstanding any shear load, but at the same time you have enough infill, or not, or you have enough you have less infill, so your price goes down, but your straight result remains the same. All right. Let's talk about other terms. So flow, how much stuff you're putting in, not infill, that's density, right? That's how much stuff you have in there. But and then how much are you pushing into the nozzle, right? You're a little bit or a lot, that'll depend on your thickness of the walls, that'll depend on a lot of things. Your retraction is basically you're retracting your filament when you want to move to other places. That will reduce oozing, that will reduce your stringing that can happen between two different, pillars. Combing is when you're dragging over the same parts, just to kind of comb it off and smoothing it out. Cooling is when you're hardening the filament. So people have these part fans. So this printer has two fans. One main fan for the actual extruder block to keep it cool, to keep it stable temperature. And then one fan for the part fan to cool off the part. So a little duct, a white duct on the bottom to kind of force the air to cool off the part as they just printed, to kind of like instantly cool it. And then bridging, we talked before, this is bridging. Well, these both are bridging. No supports needed, I'll go across. But depending on your printer, it can either do it, or it can barely do it, or you're happy here about it, or it can't do it. Right, so this depends on your print settings. A lot of things can be done with your printer as long as you have the right settings for it, very more optimized. And then spaghetti, I don't know if you have seen spaghetti before, but it's just a mess. The rat's nest, it's sad. It's sad. This is what you want to avoid. You basically wasted hours of your time, hours or money was gone down the drain here. And this is more time for you to clean a mess that is made. This is what happens when your first layer sucks and you let it print because you didn't watch on the first layer. You have to make sure you watch the first layer for all these printers because they can't fix themselves. They'll keep doing it because they're like, I think it's doing it. So make sure, try to reduce this. Okay. All right, there's a lot of accessories as well. Again, this is so CR Touch is like for again inner quality printers. They can kind of just probe around and get some bed leveling. After printing through the Raspberry Pi, you kind of monitor your printer. So you can do stuff like print through the internet, send your printer a file to print, or use a camera. You can have a PEI bed, something like this, basically. So magnetic bed is actually something I did to my printer. I used to have a glass bed, and then it shattered because I pushed it off the plate. So what happened there was actually a little bit of print shift, and then eventually it got stuck to where it kind of pushed the bed as the print shifts were happening, and then pushed it off, and the glass shattered. So now I have a magnetic bed like this, and it's easier to remove stuff. And then, yep, we have FPA, which is to help kind of pull off the print. And a nice metal extruder would be nice to suit. Extruder being this here right here, so the plastic one, you have a nice metal one to help it stop from wearing. And then linear rails. Well, not these, but these. Nice.
How does magnetic board work if the prints are plastic? Really not magnetic. What's the point of being magnetic?
Magnetic, you can take it off easily, snap it apart, put it back in, and the bed won't move. Oh, that'll move with the actual.
Oh, it's magnetic to fix the,
Yeah,
okay,
because before I'd have to use clips,
okay, yeah.
and these clips would fall off, and next thing my glass does on any shattered. So this helps remove that. Also, it's so much easier to just plop it in than to have to figure out where it is, because this also reduces the print area. I can fully print because of these things coming up. Okay. And then here's some links that you guys can use to learn some more. If you don't want to build your own firmware for your printer, I tried putting a new firmware on this, and then I took it off. I'll put it back on though. It was interesting. It was community firmware. I was gonna make my own. I tried, but it didn't work. And I'm like, you know what? I'll go back to the original one for now. But the premium one's better for this one released. Some more fun features I want to use. So I'll put it back later. Once it's better, you know, I have another printer to use. But yeah. Any questions, comments, concerns?
What are your thoughts on different brands of FDM? Like, you know, like
Print?
the spools, the plastic spools. Like,
Oh.
does Micro Center
Oh.
spools work for you or no?
So I have the amazing opportunity and honor to experience Amazon Basics plastics. Do not use Amazon Basics PLA, please. It actually made my printer not be usable for like months after what happened. Yeah.
And also if you lower quality 3D prints material, it produces more emissions, so it's quite bad for you as well.
And you'll die faster. Hey, I can't say on video, but it just bad filament will just result in bad results, bad for you, and just you look at it like, what is this? So the Amazon Basics filament, it was a black filament, okay, supposed to be.
I remember that.
Yeah,
We had it here, right?
yeah, we did. So I was like, okay, let me see if it's good, okay, as in like if it's water absorbed or not. So you snap it to see if it's not. Because if you, I'll show you guys later, but basically you gotta snap the plastic to see if it's ready or if it's good enough to use or not. Because with PLA, again, if it absorbed water, it would snap really easily if it's really brittle. But if it hasn't absorbed water yet, and it's basically not in its expired state, it'll be a little bit harder to snap off. So I was testing it, and it broke off pretty easily, right? But then you look at the center, and it's actually white in the center. This is black painted with the white center.
Oh.
And that actually resulted to my print being really scratchy looking. Because anything like hit it, it would take off the paint. And I was like, why would you just make clothing black? I don't understand. And then it caused my printer to flood. So if you see closely in right here, I put some Teflon tape or PTFE tape right here to kind of clog it up because it loosened the threads and it just started like spilling from the top and the whole thing became like a fountain of black plastic. And it was really disgusting kind of to look at because it was just like splotting everywhere. My entire bed was just full of it. And I was like, what just happened to my printer? So do not use cheap plastics. Well, to a certain amount, right? Like the average price is like 20, 25 or so. 30 is really pushing it. But for PLA, it's 25. So I use Hatchbox. Chris showed me, so our last Chris showed us Hatchbox, and it's pretty good. It served me well for the time I've had it. So I will stand by Hatchbox for now. I use eSun because it came, I've used it before for certain things. It was all right, but I got the expired one, so I can't really fully say if it's good or not because I had a bad experience because it was already expired. But Hatchbox though, pretty good. I think I also heard Overture was pretty decent too. Those are some good printing PLA and PHP brands. But yeah. Any more questions, comments, concerns, or we get the slicing side of things? All right, let's talk about slicer. So let me just close this and close this. All right, I'm going to duplicate the screen so you can see what I see. Oh, that's not. And let me change. All right, so for me, for me personally, I use two types of slicers. I started off with the free for everyone to use Cura over here. So this is free to download. You guys can download yourself if you want to download it yourself and follow along. Even if you don't have a printer, this is good to know, to have. Trying to see how it builds its files and everything like that. I also have Simplify 3D, which is a paid one, but it had a few more features that I do like, such as it can separate connected surfaces. So like if you have a single STL or a 3MF file with 2 or 3 different parts that are spaced out really randomly, you can separate them into 3 separate parts and then, and then align them properly to how you want to align it. So, and also like there's stuff like you can set to print only the first few layers, the whole entire print. So like some like finer settings that you can use. But you can use either. You can, there's also more out there, I believe. But they have the same concept of the same settings that we'll go through today. All right. So if you guys want to follow along, you guys can. But let's go to Cura. That's the free one, so everyone can use that one. And I'm gonna write this somewhere. Oh well, you get to go there. Okay. So first over here, when you first open it, you'll probably see something like this. Maybe you won't see something like this. But you have to first add a printer. So what kind of printer you're using. So send you over here, add a printer. And then if you have a printer using internet, you can use a network printer. If not, it's a lot to choose from. They have a lot of preset profiles that you can use to start off with your basic settings just to get stuff ready to print. For me, mine is the J085. So mine already have over here. And that's mine over there. And then over here, oops, it's not that one. Okay. Anyways, I did not share the screen again. Shoot. So over here is going to be your materials. So what kind of material you're using. So again, here's all the kinds of brands that you can get. There's probably more out there, but I don't know. But these are all the preset ones already in Cura. And they have different types. So again, PETG, PLA. And then I had to make my own for Orbium because I used to use Orbium, which is a specialized filament that the place I worked for to teach kids they had. So that's Orbium. But yeah, you can choose anyone. Let's say for our case, see if they have Hatchbox. Probably not. If not, you can just choose PLA, generic PLA, and you can edit the file PLA over there. And you can see that. But I'm gonna change there. Okay. From there, and over here, you have your settings for your actual part. Most likely, you'll probably see something like this, the more basic overall view. We're going to send you can check your infill, you can do support, what kind of adhesion, adhesion in general, and then how fine or how the resolution for your print is. This will change basically the layer height or how high each layer is. So depending on how thick each layer, you'll get a more finer result or a more coarser result. That will change the print time and your quality and your cost. So the more like finer you go, so the smaller the layer height you have, the more time you're going to use, the more materials you're going to use, but the nicer looking it'll look versus a 0.2, 0.3 millimeter layer height. And that will basically be more coarser. You'll have bigger layer. You can probably see the layers a bit better. You'll have a bit more gaps, but it'll save on time. I'll save on cost. So we'll print them out and see how they look. But for our case, and I would say for everyone's case who wants to go into some 3D printing, I would say the beginner side, like print settings like this, is not ideal. I'd rather have more control over everything so you can experiment with it and see exactly what kind of prints you want. Because even though this has most of the presets ready for you, it might not have everything good for your printer specifically. Because each printer, even though it's from the same brand and same model, might be a little different. So let's go here. So in custom, the 3 lines, you can go to all. And that way you'll see basically every single file, every single thing you can change. So then you have more, you see kind of how everything will affect the outcome, right? So the very first thing we'll go through is going to be your quality. So here again, layer height, that's going to be your resolution. I used to use 0.15 a lot. That would be like my kind of in between a fine and a normal-ish resolution, just because I want a bit more quality, but not too much, like I'm losing on time. Next thing you'll see is initial layer height. This is kind of important because this will dictate how your first layer is going to be, how close the nozzle will be to your first layer for your bed. So how close your calibration will be. Because what happens sometimes is that people make their initial layer height really high. So even if you calibrate your nozzle, right, and then it goes to your printer will start a lot further away, not to your actual calibration, to recalibrate again, which makes it a little bit more hassle. So I make it so it's kind of close enough to where it will not only press down on the plastic so you'll make sure it sticks on there, but it will also be able to be as close to the bed as according to my calibration. So I don't move it that much. Your line width is how thick your line is. Now this depends on your nozzle, because with all these printers you can change a lot of things. Think of them like the entry-level ones like these ones here. They're basically hobbyist printers. You can do anything you want depending on what you're doing. So your layer width or your nozzle width will dictate, again, how much time it'll take, how fine your print's gonna look like, and how much money you're spending on filament. So most standard for most printers is 0.4 millimeters for nozzle diameter for that little hole. So that's basically a standard. You can get 0.5 millimeter for thicker layer heights for layer widths for stronger parts, stronger walls. You can get 1 millimeter layer widths. So one of the time we did experiment with a 1 millimeter nozzle, and it was basically almost indestructible with the material that we had, which is already strong as it is. But that 1 millimeter nozzle made the difference. Like we went with hammers to attack it, and it still never shattered. We got the same part. We printed in PLA and the specialized material that we were using. And then the PLA being in the normal 0.4 millimeter, and then the material being in the 1 millimeter. And we stood on it. And the PLA like broke because all our weight's on there. The other one, 2 of us like stood on it, and it still didn't break. It was super strong. So I have the video of it just smashing hammers against it, but like, yeah. So again, these all matter depending on your nozzle, so what kind of nozzle you have. And then these settings inside of this will kind of change according to this outer one. So you don't have to worry about that. And then your skirt brim line width is going to be what is for the skirts and brims, which will go over in the bed adhesion section. It's basically your first layer, like how do you keep your part from losing itself in the first layer. So my initial layer line width is 150%. Basically, I'm telling it, I want more flow in the nozzle. So I want I want more filament to be going in. So that first layer line is extra thick compared to the rest of it. That way there's more material sticking onto the actual bed. So it should hopefully help with keeping stuff on it. Okay. Next is walls. As I said, the walls are basically your perimeters, or like how thick. So wall thickness will decide how many walls you're going to be using. So now this dictate how strong your part is, again, in the shear and torsion side of things. And then all these you don't have to worry about for now. Like I don't even use them because I guess more, I guess, advanced, more fine tuning. If you want to go into them, you can go into them. I don't use them enough to actually use them, but Cure will tell you exactly what it does as well. And then the light thing is same thing, like basically how far the nozzle will move without having to actually extrude anything. It's kind of wipe the nozzle clean. And then wall ordering is basically, should I do the inside first and the outside, or the outside first and the inside? Doing outside first and the inside will give you a better outside finish. But what can result is you can't do overhangs as well because of the outer overhangs first. So you can print in thin air versus building up to that. So again, it just depends on what you want to do. Most of the time I use inside to outside because I do a lot of overhang printing. So I want that first initial inner layer first to come, so I build off of that to make the outer ones. But it just depends on what you want to do. And thin walls are basically walls that are thinner than the actual nozzle diameter. So if it should print out or not. All right. And a Z seam, I wish I had a print to show you, but every single time it starts to print each layer, it'll start at a certain spot. Sometimes, for most of the time, it'll do like I think default setting is to randomize it. So it'll start at random parts of it. I put it so that it's on a certain axis, or like x-axis closest to x-axis or the y-axis. So it's in a corner where if all of them are right there, I can just like set it off really easily. Because that first is like a blob. So because it starts from nothing, right? So you first blob it out and then it'll go do its thing. So you have like a little extrusion outside of your part. So you can kind of sign it off. If you have it everywhere, it kind of looks kind of messy. So I just do it in the corner. So I specify it in the back left corner. Okay. And then top and bottom layers are how many top and bottom solid layers you have to cover the infill. So if you have no top or bottom layers, you'll have all infill, nothing else. So if you wanna like top it off with a nice clean, top, you want to put like 3 to 4 layers for the top and bottom layers, just so that there's no patches, because as the infill goes up, you'll have like holes in the infill, right? So the first layer will actually not be able to cover the entire thing. You're gonna have to put like so the filament is gonna like go a little bit and then it'll gap again. You'll see that again. I'll show you in the 3D print how it looks like. But basically, like every single time you go the first top solid layer is not going to be a solid layer. It's going to try to cover it up, but there'll be a lot of like gaps. The second layer is going to build off of that, kind of like an overhang, you could say, a little bit better, and so on. So like 4 layers usually helps keep everything like clean by the end of that. So I would recommend 3 to 4 layers for top and bottom layers, just to keep that. Otherwise, you'll have like patchy top layers. And then let's see, everything else you don't have to worry about unless you're gonna go way into it. Infill, again, density, how much percent of infill you want, how much stuff do you want in there, and then your pattern also decides on how strong your part is. So most of the time you want to use a triangle because it's one of the strongest shapes. So you gotta use triangles. It's like the best like price to performance again. There's also grid. There's lightning apparently in here. I think yeah, there's lightning. There's gyroid. There's other things you can look at how they look. But yeah, so most of the time I use like hexagons or grid maybe, but hexagons most of the time. If I'm feeling spicy, use gyroid. But yeah, it's up to that. And then everything else, same thing as before. If you want to go more into it, you can. You shouldn't have to worry about it too much. But I haven't had to deal with it too much, so yeah. your material will decide what kind of speeds. So if you didn't set up your material over here, if you go up to here and you go to manage material down here. So here's gonna be your material, like proper print settings, what density you're using, and then what diameter you're using, kind of just for your own reference. And then also what temperatures you want to run it at. So your nozzle temperature, your bed temperature, how should it be on, like when it's not being used properly, like or is this on standby or pause? And then how fast it should retract and how long it should retract. These two are crucial for clean prints. And they will decide on like a lot of factors will happen to be like retraction problems. So you want this to be correct for your material. So they'll also be over here. If you want to manually change it over here, you can. But I'd say if you want to change the material stuff, change it in the materials options. And then your flow settings is like, and how much stuff you want to be flowing, how much material you want to be flowing into the nozzle, how thick you want. Maybe your extruder normally is under extruding, so you're not getting enough stuff. You add more percentage to the flow, see how if it'll fix it or not. There's a lot of like trial and error, I'd say, with entry-level printers like these. Like you gotta spend some time to really get to know it, and then figure out what settings to use over some time. And then once you get the hang of it, you'll like fine-tune your settings over time as you print more and more things. And then you'll eventually get pretty good at it. And then yeah, speeds, again, so I'm running at about 50 millimeters per second. That's just the overall speed, and then you can see the actual like specific percentages for the infill, the walls, supports, and all that fun stuff. And then travel same thing, you probably have the speeds over here, and like other settings you don't have to touch. Usually you'd only want to touch quality, walls, top and bottom, infill, material maybe if you're changing that, and then support and build cohesion. Everything else you shouldn't have to worry about. You usually don't have to worry about. So let's talk about support. So when should we have supports? When do you guys think we should have supports? When do we need supports? Overhangs, okay, that's one of them. What else? Think about, I want a 3D print this bag, exactly like how it looks in its current wrinkly state. Would we need supports for this? No? Yes? Yeah?
That's what there's chips in
The bag, not the chip inside. Okay, where would you think we need supports?
Inside, like the,
Okay, it's solid inside.
okay.
You can't go in there. It's a sealed bag.
Oh, you're not printing the bags?
No,
like,
that's all info.
right, okay.
Yeah.
The holes were-
The holes? Maybe. We'll get to that part in a bit. What else?
the green input, yeah, there,
Here? Here?
pretty much.
Okay. What angle do you think this is right here? 45 degrees? 45 degrees?
A little more.
A little more?
15
Huh?
maybe?
15?
50.
50 up. Sure. You should not need support for this line. Because of the way that so basically what you're doing with each layer, right? If you think about each layer being like a rectangle, we're talking about physics right now a little bit, but think about a rectangle, right? Like this, right? The center of a rectangle is where?
Middle.
Middle. And what acts on the centroid? Gravity, center of mass.
Right now.
Huh?
Don't make us think right now.
I'm gonna just think right now. Okay, so center of mass will act as the center of gravity, right? That's why I can hold like this. Probably, yeah, okay. So we have two layers, right? The height, the angle at which the lowest can go, right, depends on where the placement of the two centroids are. As long as the centroid is being supported, it'll be fine. So like this angle, so 45 degrees angle or so, maybe a little bit more if you're pushing it a little bit. You can hit anything longer than this, like shallower angle, 30 degrees maybe, isn't a follow, because now the centroid is at your one arm, that's causing it to float. So that dictates on what kind of overhangs you can print, what you can't print. That's why you can't print 90-degree angles. Because that's just, there's nothing to support the whole thing, it's gonna fall over. But for a 45-degree angle, it's basically like this, where the centroid right here being supported by the edge of this one. So it should be fine. And usually this one. This one's actually a little more shallow or steeper because like this maybe. So it's not 50, but more like according to the horizontal angle, it's more like 60 or 55 CD ish. So you're actually fine with that. So that's what depends on support wise. So for this right here, for this one over here, do you think we support for this one? What angle is that? 40? I don't have prototype, so I can't tell. But when I look at it, this could be fun. And this is the same reason why these poles may not need supports. Because the other wants to shrink as well, so it'll contract itself, being in tension, or yeah, in tension. So over here, it'll kind of keep itself from falling over there. So a little bit of physics. If you guys love physics. Well, are we all E here? No, you're not E. You're not E. Yeah. Let's go. Okay. Anyways. So again, so for really steep overhangs, then you need supports. So we'll put a print and we'll see what happens with that. And then there's densities over, where are you? Right here is how much stuff you want. That's 0. But how dense your support should be. You don't want it too thick, like your infill thickness, because that just means like it'll be as strong as your main part, which makes it extra hard to like to get off. Usually you want like 10% in support infill. And then support brim, I'd recommend support brim, just like basically a little hat on the bottom, on the first layer for support to sit on, so it doesn't like fall over. So it won't like knock over. Kind of basically expands the surface area of that first layer of the support because it's so thin. You'd want a bigger surface area just for it so it doesn't like fall over. Okay. Then we have build plate adhesion. This is the skirt brims I was talking about earlier. So a skirt is basically an outline of your part. So if I were to print this water bottle, the first layer would probably be the base, not the cap, because all the mass is gonna flip over. Nice solid base, large surface area. You only need to have a brim or a skirt, or not a skirt. It is like a solid circle only, because a skirt is just an outline around the part. It doesn't do anything for the part. It's just more for you to make sure that your thing is calibrated and that there is filament in the nozzle. So when it starts printing, you don't have like a part with no filament. So when the print first starts your first layer, you'll always have filament ready to go in the nozzle. Because what happens usually is when it first starts, the filament still hasn't built enough pressure yet to actually extrude out. So you have to wait a little bit. So the skirt is kind of there to help you calibrate and prime the nozzle, so the nozzle has enough filament in it to get the pressure to start printing. Now, for to print it, this ball here, you have like 3 small faces on the bottom. Actually, more like this, because there's little holes here. So really small surface areas. So then I put a brim on there, and there's extra layers that are like a skirt, but it's connected to the actual piece on the bottom. So like a little hat, like a brim hat, basically, to help increase the surface area, so it stays on the part. You already see the brim of my last part on the actual build plate here. You can see the outline. The part actually started, so there's just a port over here, but the part started over here. So put a little brim just to make everything there, so it stays safe, so that it won't knock over as the build plate moves back and forth. And that's your skirts and your brims. A raft is basically if your build plate sucks, as in it's holes in, and just like other damaged stuff, like your build plate is basically unusable. It's just kind of there, but it's not really there. So use a raft, kind of basically like a little raft from like in the ocean, you know, or a river. But you kind of basically have a little island to where it has enough material, or it can have like a nice level area to start printing. So if you have like a lot of build adhesion issues, that could just be your build plate being a problem. Just use a wrap and see what happens. Because the best way to like things want to adhere to themselves the most because they're the same consistency. So yeah. And that is a brief overview of what you're going to be changing. So let's talk about where to go for stuff like this. So this stuff I don't want to. Yeah. You guys can go on Thingiverse, so THINGIVERSE.com, and you'll have free STL files, GMF files, all sorts of files that people will do and make. So a lot of stuff you can 3D print. Some stuff you gotta make sure that it may not be 3D printable. Because I'll look and see, depending on your printer, if it's possible. A lot of stuff can be like printed in place where basically it's like a tolerance test. Or if your tolerance is right, you can print a movable piece in a single part. We are not break it still a little bit in the inside. But that's just like kind of being smart with the layer heights and like how you model your parts. So if everyone wants to go on to Thingiverse and find a piece they want to print, that'd be very nice. It is Thingiverse.com. Oops, that's not. Yeah, Thingiverse. Here, where's Thingiverse? Okay, there you go. Thingiverse.com. I will turn the printer on. All right. I just want to have a print in mind. So then we have something to print when we're ready to print something. Huh? The chubby crocodile? Hold up. This one?
Yeah.
Okay. Sounds good. It will take, okay, how long do you think it'll take?
How big is it?
How big do you want it? You small?
40 millimeters?
Oh, bro, you're giving me the whole, like, gotta look at the, let me just see how.
I'm gonna say 5 hours.
5 hours and 40 millimeters?
For this, not 5 hours, more like an hour, maybe
Wow.
2.
Good, good.
If it's 40 millimeters, it's kind of small.
Yeah.
I've also printed a lot of this size for little kids, so I would know.
How about detailed stuff?
They won't show up.
Okay.
They'll barely show up, maybe. But if you want exactly this size right here, all you know will take.
What size is that? Like palm size?
And imagine a desk.
Mm.
So a shelf yay wide.
If you scroll down, they have.
Oh yeah. Let's look at the dimensions. Yeah, these are bamboo. All right, 68 by 53. It's like
Yeah.
yay high. 4 hours maybe. 3-4 hours. Okay. Everyone found a part they want to print? Let me see how all right. Let's slice something that is not that right now. Do I have a cotton skew? All right, I'm gonna make a calibration skirt. You can see. Oh my, wrong thing. All right. Or should we do a Benji? Let's do Benchy. All right. It's your typical Benchy print. So a good benchmark for the printer. So for Benchy here, okay, we're gonna print it with no supports with, let's see. Should we put a brim or a skirt for this? A brim? I'd say for how big it is and how big the first layer is gonna be, a skirt would be fine. So we'll do a skirt. And that's good. So I don't know if my settings for Kira are right because it's been a while since the last use Kira. So we can see how good my settings for Kira was versus my simplified settings, kind of combat those two. So I'm just gonna slice this over here. I think I'm setting supports. I gotta supports first. So no supports. Then it's all right, so 4 hours for this one. Do you want to wait 4 hours? Okay. So we will scale this down and hopefully it'll be smaller. All right. It'll be a good like starting for a first layer to see how we can do something like that. So we will put that in there. So one cool thing about G-code files are you can actually see them. So if I were to open up VS Code right now, and then open up a G-code file from, let's say, the SD card of something I don't want to use. Do this one. Oh my God. All right. Okay. Okay. So this is the G code for a gear file. So let me show you what it looks like in this one. So this is the file, the G code file. You can see the layers right here and how it's going to build it, right? All this is stored in code like this. You can see that they put comments just like this is my 3D software and all those settings that I made for it. And then in the actual code down over here is the actual machine code used to make it go somewhere. So you can see like G1, X this number, Y this number, E this number, F 900. So the G being like, okay, move the nozzle, sort of X coordinate, Y coordinate, and the extruder motor in a certain amount, and then feed a little bit. So this will, you can change where the position is using this code. So you can actually modify, if you want to make your own code, just type it out for a part, you could do that. I wouldn't recommend it because as you can see, just for a gear file, this is about, let's see. What? It's like the 332,541 lines of code. If you guys want to do that, up to you guys. But I wouldn't say you should. But you know, you have a summer project to do. Write some code. Here you go. You can actually change G code in software like these like study software like this. Like on Simplify here, I can go into scripts And here I can change what it should do before it starts printing anything. So for instance, on simplify here, I'm telling it to home all the axes first, and then prime the nozzle, and then wipe it afterwards. Kind of like give a nice, like make sure it's all ready to go. And then after it's done, it should actually beep for a second to tell us, oh, it's done. So that's stuff I added myself so that I know that it's ready to go. On Cura, you can do that as well in the machine settings over here, manage printers, machine settings, and then there's your G code, start G code, end G code. So on Cura, let's see, I beep for a fourth of a second to put in there. So just knowing it's a little bit of code, and then you can do some fun stuff with that. And certain printers have actually a variable like buzzer instead of a constant one like mine. So you can actually play a whole theme song if you wanted to kind of finish it off. But yeah. All right. So this is already in the D card. There it is. So before I eject it, I'm gonna put the same one. Every printer has the same G code file. G code is just the code of each layer, so they can translate that. That's a machine code. So, for instance, these are all Marlin. Well, this one here is Marlin based, so you can change the G code flavor or like the type of G code you're doing based on your printer. So mine's Marlin based, so any Marlin printer can read my printer code, even if it can't do it because it's not a smaller printer or a larger printer. It'll try it because it can read it. There's other stuff as well. Like if you go here, I believe in where else? Other G code scripts. Yep. Go to the tab. Output.
So if it changes, what I used to say is
Yeah.
so I'm saying if I'm using the same printer and I have multiple, you could
Well,
same
same format, as in .g code file that we're talking about. Talking about the actual code itself.
Yeah.
Oh, okay. So if I were to go back to this VS Code right here, oh, this is the G code for the gear file, right? That one is over. I can open it up again. Over. Oh, that one you can set. So for me, since I set it start code to be started in one and end to be started in one, it will be the same. It'll add that onto the other varying ones. Because that's a constant, it's a start G code, what to do at the start. So I'll change every single time. But the actual G code for the part, that depends on your part. All right. So I'm gonna import the same CL file over here. How much did you keep? What scale did you give it? So let's actually give it 60. All right, so we'll go here. So here it's over here, 60.98. And then, so here you gotta look at the layer. So 0.2, on the other one was 0.15, so I'll put 1.15 on this one as well. Additions, I'm using a skirt. So for this one, a skirt is defined by your offset. If there's 0 offset, like this one right here, it's a brim. So if I give it like a 1 millimeter offset to the skirt, because skirt and a brim are the same thing. The brim is just a skirt that's stuck to the actual part. And I'm gonna lower the amount of lines I'm gonna use. And then info. I think should be good. 15%. Yeah, I think it should be good. And you'll see right here again. Just how to look. So Cura here, you should see over here. So that's going to be your part right there. And you can see how it's printing. It's going to start on top. The bottom here. So that's going to print. So that's the first layer right there. And as it builds up, it will do this. And then for simplify, similar process. You see that first layer is that one over there. And then it'll build up with that. So similar. So we'll see depending on the settings, because some settings are different. I believe speeds are different, and the layer heights are different, I believe. And we'll see other things. We'll see how, because each slicer is slightly different on how they take it, even there's the same sentence. Okay. So I'll add this one to the same one. Yeah. Okay. Let's this and put it here. You're gonna come over here and talk about the printer itself. Okay. So let's talk about what we have over here. We have the build plate, we have the gantry, and then we have the Z screws over here. The extruder like here. So this is the Bowden FDM printer. This is the Bowden tube, which is kind of crucial to this over here. So this extruder right here will create the pressure needed to kind of push this into the heating on and on this side, and that will give this to like a hot glue gun basically. So you go over here, you see heat, and when I preheat the nozzle in bed to about 200. So my settings are for this PLA right here is 265 or so. I'm gonna go over here. 200 PLA?
Oh, I think like 265 for just the.
No, 200 for the. I can't hit 265. But on like filaments like this, you'll see the actual what kind of temperature you're gonna use. So this is 210 to 230, but I use 200 because it's a bit better. So actually, that may be why it was clogging earlier. So actually, let's fix that. I think because each color might also change what kind of temperature you're using. Because earlier I was using white filament, which had a print temperature of 200 or 210 or 2, something like that. So we'll update the temperatures real quick, and then we'll be back. We'll be right back. So temperature.
Yeah, I'll do 200 at first too. Kind of like get stuck. But now
Yeah.
string.
Oh,
I was gonna ask you.
stringing. We'll talk about that in a bit. So let me make this into a piece, and then this one here. Go back to this one. Go to temperature. Where is temperature? Why can't I see temperature? Material, sorry. Yeah, it's been a while. It's been a minute. All right. So this is 215. Because see how everything else kind of changed by itself? So that should be better for this print. And then we'll send the first few layers and see how it looks. So note how this is 1 hour 25 minutes for this one. And then this one says 1 hour 36 minutes estimate. So one's a bit faster than the other, so we'll see what really happens here. All right, I think it should be okay. So all I'll do is let's heat up the nozzle and bed. So this right here right now, but my printer is the nozzle. I'm gonna do this twice, so 200 and 15. Okay. That? All right, you can wait all that. So now, I don't recommend you taking nozzle now, because heating. So the heating element is actually this slither right here that goes across. Okay, that's a heater. It might kind of be used, as you can see, the wires coming off of this. So, and then you have your cooling fan duct back here. You have your nozzle over there, your heating plug, kind of your important stuff. And then, yeah. So it's heating up. Let's say it's about 200 or so for here. I'll take off the filament from here for a second to show you how to snap it. And then you have a calibration. I didn't move it all the way here. Also, back is down here is there a Z limit step? Or C limit step concept? So basically your home position, how low it is. Depending on how thick your bed's gonna be, Not the raise or lower that. So be careful that one. And then your X limit right here. There, my Y limit's inside here, so you can't really hear it. Right? You can hear it, you can't see it. So like, that's your, so homepage right here. Yeah, that's your phone. Plus your reference point is that top left corner. Top left left corner. All right, I'm gonna yank out the filament right now. Let's see. All right, here's a filament. This is like relatively good filament. You kind of bend it, see, it's not brittle. So it's been out exposed to the temperature and like, you know, the air, the water in my sunroom that's existed because of some rain happening. But if you go further back, kind of a little harder to break off. It's more like newer here than at the tip where it was all old. You just want to feel that you can break a little bit of it. So that's how it should feel. Is if that's good filament, it'll be like that. So, yeah, that's, I mean, it's, you know, it's not expired yet. So, no, I actually don't have scissors today. And yeah, it's been a long day today. I can't. It's too good of a phone. Yeah, I think Xbox is the MVP, but there. You went one or that one. Yeah. Don't use it, zero calories. I believe it is FDA approved.
No, don't need it.
How long does it take for like if this whole school is out?
Huh?
How long does it take to expire?
So
Like if you leave in your garage?
6 to 8 months, I think. Usually once you start, like, we open the pack from the vacuum seal pack, we want to finish it off ASAP. Because depending on where you live, you know, humid or not, and like, since it's almost summer, it's probably gonna be dry. So it's fine, but like, in the winter time, nip that. I try to, when it's about back. The store in like a, you know, not a damp place. I gotta wait for this to take off. Anyone else wanna make it open? Very good. Okay, cool. Let's hope that this won't cause a problem. Huh? Huh? Yes.
Yeah.
You're supposed to, but guess who's on a wire cutter?
Keeps it with the work downstairs.
Yeah, I came in a rush because I have to export the other pin from that room. I feel like. So I was about to run I was like, it's being a little late though. So one important thing to note with filament in general, when you have it like this, where it's not anything, never let go of it. Or at least keep it in like a clamp spot, like for instance, on the spool itself, you have like these little spots. You gotta keep it in there. The moment you let go of it, it could tangle itself into itself, and then you have a knot. And then you won't know that there's a knot there because so many of these lines. And you can actually just push yourself back as it keeps extruding, right? So you won't notice it until you do like a large long print. Let's say a 5-day print you're doing large, right? And then right at the end, that knot decides to seize up. And next thing you know, it can't extrude anymore because of the knot forming. And then you lose your 5-day print on the last day, on the last few minutes. That's happened before, by the way. So it's not fun. So always make sure you have it, you know, under tension. You don't want to ever let go. Like let it be free. And then let's see. Gonna put it back in the 1 and 2. And then I'm gonna manually time normal now. So once it hits the, there you go. Coming out now. Yeah. Nope, good preference. Oh, that's a problem right now that I'm having with this one is this right here may not be cropping down enough. So I'm just gonna hope that it'll be to print something for you guys or how big is it? Okay. Yeah, that's good enough. Yeah. Again, don't inhale this like, you know, what you want to do.
Yeah, also, other note, high emissions are in the first 5 minutes of printing, so we might all want to take a step back.
Anyway, so now that we're there, let's talk about calibration. So now the bed and the hot ends are hot, right? So you go down here, you calibrate. Okay. And you can see that's not at the first level, not C level. I can see it. It's in the first home itself. And then it's gonna go to the first corner, the front left corner. Now I'm gonna see. I don't have a piece of paper. You have a piece of paper? Thank you. I took everything out of my backpack right in.
See what they're watching.
Huh? How close is the nozzle to the bed? Looks touching, right? I think it's very much touching, so I'm gonna lower it. So you have 4 points of calibration. This corner,
Use my notes.
that corner. Your notes.
My notes from last week.
Oh my god, man. Okay. If you say so. All right. Usually I use 1 or 2 layers of paper. Because you'd rather have a nozzle that's further away from the bed than actually on the bed. And you have, you have broken. So you put it on there. Feel it. How does it feel?
Good friction.
Email on.
It's like rough on it.
You're up on it.
Only one mistake.
What face? No on it.
Oh, yeah. There's too much color.
Yes. You want to lower this slightly because you're almost there, but not quite. So you want to spin this first knob this way, like you're screwing it in.
Counterclockwise? No, clockwise. For me.
The same way for all of us.
Oh, okay.
So use one hand to kind of move it around, and use the other hand to kind of to change the rotation to see whether you're actually doing the right way or the wrong way.
You want to do less tugging on the.
You want some tugging, but you want a little bit less.
Clockwise, right?
Counterclockwise.
Yeah.
Think of it like a bolt and a nut. That's what it is. Like you're on the nut, the bolt.
Thanks. Yeah.
You just go through more, like what's the ideal amount of like friction that you're comfortable?
I'll tell you after. Gotta make sure everyone knows how it feels first, and then I'll look at it and I'll tell you exactly what it is. What do you think?
Maybe it can be a little bit looser.
The looser?
Yeah.
Well, I didn't feel it yet. Like you did without you checking it.
I'm
Okay.
trying to remember from last workshop.
Oh, I see. Okay, using your last workshop.
Okay, so.
Okay, thank you. That's pretty good. Again, I choose to go have a bed that's lower than higher because I don't want the knobs to hit the bed, right? So you can fine tune this later on to put a perfect first layer. So this, I'd say, is pretty good. It can be a little bit higher, but this by itself is pretty good. So go to the second one.
Second, oh.
So what's happening here? You can also feel it, by the way. Let everyone have a look. Let everyone else make sure.
They're not moving.
Oh yeah. Move, people. I want more interaction.
Oh, I'm a visual learner.
No, you gotta make sure.
You can tell.
You can't just tell.
No, but by them pulling on it, you can tell.
Yeah, what if you're by yourself?
Well, right now I'm learning, like I just said.
All right. So too high or too low?
Too.
Too high? Want to do the next one?
You want, I mean,
I'll
I
take
did
the
the next one, we have four.
Yeah.
Here now.
Okay, you get the really hard corner because that's the fluid right next to it.
Is it,
Because one, two,
it's
three,
hard
four.
to like.
It's a annoying one because then what happens for me at least is the entire fluid spool falls off. And then I'm just in pain.
Can you just like kind of move it a little bit? Like while you're doing it?
Moving what?
The
Yeah. You just take it off.
This is how you're like fine.
Yeah. And then there's a level, after doing it multiple times, kind of the what's it called, the margins.
Okay.
So to where like now I just eyeball it. Because I just look at it, I'm like, it's close enough. And then usually it's close enough. But your fine tuning will happen on the actual print. So that's pretty good. So next one, or one look at this one. I'll help you on this. All right.
That's better.
So it's right here, back right here, next to the cable. So it's the most painful spot.
You like purposely mess it up a little bit?
So what happened was, for these printers, when you move them around, they get messed up. And I moved it around, and it got messed up. Because I had to lift it into the car, drive in a bumpy road.
If you don't move it and the calibration stays the same, like you don't have to do this every single time you print it, or you.
Depends on you. Depends, because if you have a print that's a bit too stuck on, in your build plate, let's say your build plate is not removed, right? So you're just printing on the actual plate itself. You can actually like use a scalpel or something to kind of pry it off. That movement's gonna loosen the screws. You'll have a bad calibration. For this print, for this plate being magnetic, I just lightly just take it off. It doesn't need to do anything. So maybe some slight adjustments, but nothing too like the whole thing again. Like now I get home, I gotta actually make sure that every corner is fine, because even if you cover right here, like by the time I get home, it's not gonna be messed up again. So I gotta lift it again, move it around. Okay. Is it good? You can check.
I get a little bit too high. Maybe, I mean, it's a good ratio though.
I'd say it's pretty good. On the ballpark, it's looking good. So for this one, it's like your coarse tuning. Like get out of the ballpark, something like be perfect right now. Make sure it's the bed is lower than higher, because then you won't engrave into the bed on accident. All right, fourth corner. Look at the hardest one. That's over there, yeah.
Yeah.
Oh yeah.
Was it all tight like this?
No. I don't know what you're doing.
This is the one, right?
Yeah, that's the one. Is it not
Oh, the screws kind of hard.
the back ones?
Or like all of them, like this.
It's not unscrewing.
Oh, no, you're not supposed to screw.
No, it's not moving.
Are you lowering or raising the bed? That's my first question.
Crazy.
Why are you raising the bed?
Well, I don't know. I was trying to see if it's moving.
Probably you're raising the bed. It's already high where it's like not getting it.
To the opposite.
So you want to go counterclockwise.
How hot does the bed get?
So my printer here can go to 110 degrees Celsius. I've actually tested at 105. Again, putting Pop Tarts. But what do you mean? It's just a heat plate. Come on.
I feel like it's easy to like.
It's not like-
This is so wide.
At 100, like past 80, it's actually really big. It stings.
Can you like feel the heat?
You can definitely like already feel the heat as it is right now. Like, but like at 80 degrees or so, like when you touch it, especially the aluminum on the
It's like
bottom,
those-
it will.
I don't know.
But yeah, especially aluminum, it will actually like, after a while of holding it, it will stick.
I mean, it's still
Is there a
stupid.
reason to have it really hot?
For different materials.
Oh,
Yeah, this is too high still,
So,
lower.
lower.
yeah, I definitely have mine too high on mine. Mine's like, whenever I do it, it's like how it first felt.
Is that what I felt?
Yeah, like
Maybe.
super friction. I wasn't sure how it was supposed to feel.
So lower is clockwise?
Lower is counterclockwise. Think of it like a bolt kind of that. So you have to in order to bring it down, you have to kind of rotate it so that it's. Calibration is number one.
I should run my printer, bro, so you can see.
Like, you want me to fix this? Maybe though. Yeah, bring it.
No, because I feel like even like in the middle, it's like messed up. I don't know.
It's maybe like a bow, like your fed's like this. This is good enough. So I think it's a little, according to everything else, it's on the higher side still, but you can work with it. Because as long as you can use it like natural side, you can only easily like bring it in and out. A lot harder.
Yeah.
When you guys do calibrate with paper, make sure you don't actually push down though, because you're gonna push on the bed. You want to actually. So what I would do is for this one, I kind of lower this. So maybe like it's a little smidge, and now it's like a bit better. So I can use it to be able to easily like third it. Okay. And then good step. Good. And how does it feel?
Pretty good.
Pretty good?
Yeah, there's like a little bit of friction.
Right, what else? Make
Oh, yeah, it's good for like according to all the other ones.
So by calibrating, the four corners, it's automatically calibrated.
no. That depends on your build plate. If it's warped, then you have like a bow on it or a little sag. My build plate here can't sag. So if you'll see, this is actually very low. This is not good. This is low. Like because I can like easily, there's no friction really. So I'd want a little bit more. You can back to the first corner. Remember the last time, it should have changed a little. So see if it's changed a little.
Yeah.
You do it over and over.
That's because each corner changes each corner. As I told you last time when you were talking the problem.
Yeah.
So each corner changes each corner. So to combat this, you have to like simultaneously change everything else that could possibly change to help fix the corner. So depending on how each corner is and how the center is, so this is not too low. This is way too low now, right? This is like you can feel it. It was like perfect before. Now it's like there's nothing there.
Friction.
Yeah. So that means when you're like raising up, so what do we do here? We lower this one over here, right? Did you raise or lower this one?
Lower. Reload all.
Lower this one, lower this one?
I think lowered all.
So that lowered the first one as well. Cool. So as you raise this one, it might raise everything back up. But so as you raise that one, these two will be the first ones being affected mostly. And it's slightly affected on this one. So you have to raise this one, lower this one, and lower this one slightly. Okay. So you gotta kind of like balance the game of everything. That's you gotta notice that. That's how I do it.
Ooh.
But let's pretend this is good. What's the first thing gonna look like? So if you guys wanna feel it, I'm gonna go back here to save and disable the separator. So now I can move this around to any position I want. You gotta kind of feel of how the overall build plate is right? And overall, it is very loose. Except for this corner here. This corner is nice. And it's loose here, loose here. So it is this corner is a bit on the, as you lower this corner, everything else went down. So what do you think is gonna happen with the first thing? Knowing that this is like problem.
What's the thought? Like slip off.
Yeah. So what you'll probably get, because in the center it's already like pretty low, so you'll probably see it kind of like even-ish, but you know that on the extremes, this is on the better side. So you'll see the beads I was talking about earlier. So let's do that. Let's go print this print. Hey, no. Okay. It's like, yeah. Depends on if I preheated or not. If I preheated it, it should take about 30 seconds to a minute to start. If I didn't preheat it, it'll take 30 minutes to start. So
30 minutes.
because what happens if we don't preheat it, it'll heat up the bed first or nozzle first, and the bed is like a large area. So it'll take a long time just to get the whole thing up to level. That's why I preheat it first. So like get it normally up to like I don't know what the temperature's saying right now.
What was the left one?
For both like
They're both max 65 and 215.
okay, so I should start soon. So let's see though. So first step is to wipe the nozzle. So let's do that first. Right here. So I'll prime the nozzle and wipe it off. So you'll see some stuff happening. I hope it doesn't like
Oh, there we go.
all right, let's see what happens. Now I don't know if this is what's the file name by the way? Huh? What's the file name?
Iron Road energy.
Okay, so this is the simplified file. Okay, you see the layers right now? See how thin they are? You see how it's basically like a thin bead, like a string? So this is the bed is way too low. So you know bed is way too low. Right? You see the each of the lines are not touching the rest of the line. A good first layer is a nice flush first layer. All lines are connected together as one solid first layer. So in order to let this print fully, you'll have like the stringing happen where like you can kind of just, like hit outside of it and it'll like come because all the layers are like different or not any better. So let's fix this. So first thing you can do is you can raise all the other corners. So because I want to raise those two corners, I'll raise
Should we
this one.
stop it?
No.
No. Oh, because you want to calibrate.
So the fine-tuning calibration is calibrating while it's printing. Because then you'll know exactly how close apart. Because this can only give you so far, like details wise. So you stop the print right now. And then reheat the head nozzle so it doesn't pull off on you. And then so yeah. So this is what you don't want to see. Peel it off. See how easy it is to peel it off. Yeah, that's not a good print. Yeah, exactly. Even with the right here, like, you can easily take it out. So you don't want this. You guys want to? You guys want to reuse this again? And you want to reuse this again and try to recalibrate, or do you want to use a print recalibrate?
Print. Oh, like the.
Do you want to print something to calibrate, or do you want to use this to calibrate this?
I don't want to print them.
Okay.
Maybe we could get wider print.
Oh, wider print. Okay. Let me see what's on the SD card. I think I have something.
I'm gonna get some pizza.
All yours, buddy. All yours.
That'd be a little cool.
All right. We'll do. I think what was this? It's not.
You do like one layer.
Huh? One layer. I can do one layer of it, but I probably have to like redo the. Oops. What's wrong? Okay. I'll find something that's nice and so. I have to. Nice first layer. All right, we'll do one of the keys from when we did the escape room. Now I'll make it extra big. So. Okay. A nice large key. All right. And we'll do this one. All right.
There's a specific reason you include that escape code. Huh? Is there a specific reason you use that?
Because this accepts the SD card?
Yeah. Sorry.
Because it accepts the SD card?
After you use it.
Yeah. I mean, okay, I can use a USB. There's a USB port on this side right here. That means it to be connected to the laptop at all times. So there's no machine off the computer.
Is the flash drive transport?
You can, but the USB is a USB type B.
What?
Hey, the USB type B. So you know, it's like the instead of the no more thing, it's like a little. You can look in the corner. Like for art, yeah.
That's like the cable, but maybe you can make it go up.
Yeah.
Oh, I see.
Yeah. I mean, you
Like what
could
we usually use for,
Arduinos and
I was gonna say printers.
that too.
Wait, so with that kind of USB, you like Raspberry Pi with it?
They'll if you've already a cable, shut.
So is there a reason it uses like an SD card to do a flash drive? Is one better than the other?
No. I don't. Printers can use whatever, but it's just more compact to use, like because we don't want things to stick out. You can put it in. Because I've had a time where someone else's printer was a flash drive, and we walked past it.
Oh, yeah.
That's not fun. So yeah. All right. Press print and see what happens. So we print. We press that. And print.
Oh,
And then click the next. And next. And next. And next. There. That last one. No. Next. Oh. All right. Huh? So this was our 3D printer escape room that we did a year ago. 2 years ago?
It's so bad.
A year ago?
A year ago.
My memory's
It was a
gone.
disaster.
It was such a pain.
For us, it was a disaster.
I have all the parts just broken right now in the room. It's so sad. Anyways,
It took forever to set up.
that was a thing that happened.
We were very understaffed, so it was the
Yeah.
best.
We were losing sleep in time. It's fine though, but because now I have 5 key files I can use to pick locks that are of the same lock. I don't know.
Didn't Sam stalling for like an hour? We figured out it's already up.
Don't remember, man. All right, let's see. You guys have to come here though, because you have to calibrate while it's printing. So if you see the beating happen again, lift the corners up. If you see it way too high, you'll see what will happen is it'll kind of fade away. And then you'll be like, okay, you gotta lower the print. So you want a nice flat plate. So as you already know, this is already back calibration of this. You might want to lift up to that corner right there. So I'll lift up the back once we can't get to it. So I'll show you.
That was a huge key.
Yeah,
That's this
they
one.
wanted a large surface area.
Now I'll do just a little bit. Okay, this
So-
one.
So you see right here, the bed got way too high to where you see the part stop and it stopped working. It's not the other way. You don't want that one. And right here, it's not bonding with the two are not good, right? But it's okay because the previous layer wasn't good. Right here in this corner, you see the layers are kind of meshing together now. So that means that this area is closest to is fine. This is still kind of bad, so I'm lowering this corner. So this is all pretty decent. Can you get closer?
Oh,
So you're getting there.
wait, is it connected yet?
They're
Oh.
connected. There's still a little line though, so you're almost a little off. But it could just be your previous layer was also, your previous line was right. Then, now this is a bit too high, see what's happening there? So I'm gonna lower the back, because I think when you raise the front, I gotta lower the back to counter it.
It's easier with this kind of plastic too, huh?
Your PLA?
Yeah, because mine's just black, but I can't really tell. It's a little harder to
With white and like up there, that's black is the same. If you start with black background, it's actually the same. But the worst is see like translucent element. So this is still way too high for me on 40. Okay, you like
Oh, I went too far. You stopped it.
yeah, stop it. Press the stop button.
Not bad.
Bro, really shot my trainer, man. It's my personal printer, dude. Don't break it.
Sorry.
Okay. Well, this is a good stopping point to see what they made. And then also to fix the hey. Oh my god. So if you now we can raise it too high. So you shouldn't have to raise that high. So
Which will come off if it's too high.
yeah, because it's better to get off and replace it if you need it. The heat plate. But let's see. So you see the back right here is the bed was way too high where it just basically stopped working. It kind of engraved into the tape right here. So I was trying to lower it, but you kept raising it. So you see right here? Again, same thing, it's way too high. You hit a perfect spot, but then you start going high, too high on the corner. So
It's a good lesson.
yeah. But at the cost of my printer
My bad.
today. So go to learn. Okay. So heat up the printer again. This is why people hate 3D printing, because at least in this like budget area, because it's a pain to start, restart, because you don't have all the full like fixing by the way. Oh. So it's also not fun. That also might have caused the problem too. I gotta get that fixed. Anyways. That? 65 right there?
Yeah, 57.
So the first thing I want to focus always on is calibration for anything else. Once you have calibration right, everything else will be fine. Or it should be easier to figure out. But that feeling for calibration is the first thing. Take it all, man. Take it all. I'll throw it away afterwards. I'm not going to eat it. You want to take it, just take it.
How many are just like office?
So, yeah, whether you had pepperoni, single cheese, I might eat this single spoon. And then more cheese, and pepperoni. And then you have more cheese.
The milk label, the heat up the pizza.
No, don't do that.
You know, I have ingested enough like plastics for my day. I think I'm good.
Don't let it.
My wife told me about this.
Alzheimer's? What?
Yeah, well, microplastic does everything, so, it's fine.
Is it all from you too?
It like, one year, your rates of Alzheimer's.
So that's what.
Don't eat microplastics.
Period.
I'll say this again.
If you can.
Don't eat microplastics.
But they're so good.
Like the Yash.
They're colorful. They're so.
No, there are plenty of colors you can get from food, like natural fruits, vegetables.
But it has that
No,
carb.
no
in it.
one.
But
Wait, I have a question. Let's say you.
all right.
That one has microplastic in it? Oh, then it's never.
I mean, you
All
can get
right,
into, like,
first thing is
water,
the-
microplastics, soil,
Understand.
Alright, what do you guys think?
Looks fine so far.
That's too low in the front.
Oh,
You can
here,
tell from right there.
oh,
Look at it, look at it. You can easily move it off. That's too low. In the back, you can also feel like the fed's way too low on all sides. Or it's either that or it's not extruding enough filament. So,
supposed to be closer.
yes, so that's what we need to get off. So raise the bed. Let's go a little bit, go small increments, okay? The small increments matter a lot. Because you're thinking about a 1 millimeter distance, so small increments are a lot. So you kind of feel around, so. It's kind of, okay, the reason probably why, because this is coming off. All right, I'm gonna hold it down while you guys calibrate.
Oh, it's still low on that side, oh, it's just,
So maybe it wasn't low and it was this thing not working properly. Cause yeah, it was under extruding a lot, so. That's not proper. But what do you guys feel? What do you guys see? Change it, if you guys need to change it. You guys have the entire printer to your calibration. I'm just holding those. Okay, what's next? Okay, play your scratch.
can I touch it?
Yeah, go ahead. Just don't jam your finger into the,
So if it's still kind of loose like this, then,
that's too low. Remember to make sure you get all the corners, not just the front two corners. The back two matter as well.
does someone wanna go on the other side of the table?
You in a row. Me? Redemption? Wrong.
Oh, I mean, the other side kind of sits.
Well, that's the inside. That's because it's also due to the other ones. Remember that. Everything affects everything. So you gotta make sure you have a nice balance of everything. Huh?
I don't know, I feel like it's okay for me. Yeah,
Once you get it down though,
Oh, yeah.
Yeah.
Good.
it's okay?
I don't know. Look at the layer. Look at how they're stuck together. Are they sticking together? Are they lined? Or you can see the visible lines. Like
I needed to like make a better pass.
is it a flat ribbon? That's the question.
It looks kind of separate still.
So it might be a slightly lower, small adjustments, micro adjustments.
There's very little, I think a little bit on every. that's
Yeah,
like at the very
you
middle.
remember everything affects everything. Okay,
Like a quarter of a turn.
not wait the 8th of a turn, 16th of a turn,
Like a 16.
Yeah.
32nd of a
One-
turn. Not even like so much like extra stress for no reason on here.
I don't remember doing all of this last time.
You don't? Why not?
Maybe someone calibrated it perfectly the first time.
I think so, probably. Yeah, they're still separated though,
Yeah.
so might wanna tune something.
Ready? Separation needs to low.
Yes. Because if you think about it, if the bed is too low, then it's not pressing down on each,
So they're not like
yeah, it's not flat enough.
connected.
Is you wanted to squish a little bit.
You wanna squish it enough to where the entire, like, if you think about it,
I
it's a
think
circle,
we
right?
did.
so you have a diameter of a circle, that's like 0.4 millimeter or diameter, right? So you want each line to be 0.4 millimeters, 0.6 millimeters, right? So to squish it down to its half length, right, to get a nice flat, like proper diameter length. Think about like you can get that waterfall, right? This is your, each layer looks like this. If you put it down enough, it'll expand to its, proper diameter. So that's what we're trying to do. If your bed's too low, it'll seem like this. You have a really
Yeah.
small contact patch. Versus like you spin it down all the way and have, I could just explode into the, Anyway,
Yeah, that wasn't a good idea.
it's okay. I knew I closed it off. But yeah. Yeah, that right there is some bad calibration.
Yeah.
Like, terrible.
Yeah, I know. Can I try it
Yeah.
again?
It's a finish line.
I don't think so, man. Last time I checked, you're pretty good when it was sitting before it conveniently stopped working on the voting tube.
It looks slightly flatter than.
Then you're making progress. And if the bed is too high, you start seeing the plastic make little like valleys every single place the nozzle goes across because it's too low. The nozzle it has to go somewhere, right? So it goes to the edges of the nozzle, then you get these like ridges. So
It's still way too low.
fix all of them, not just one of them, or else last time will happen again.
Alright, so we're just.
I don't know.
Can't really touch this one, bro.
You can't touch it. What are you talking about? You gotta go underneath the. You get there.
Yeah.
If I can do it, you can do it. Getting closer though, that's for sure. Never go small increments there.
I know,
Change
I
everything.
have a strong urge to just like.
Yank it, just
Go.
go full on. Yeah, and
Break
next thing
that.
the whole will go up again.
It's a flatter, right?
Yeah,
Compared
looks
to the outline.
yeah, it looks a lot more combined. I can see less gaps. Because this is why you watch the first layer. So you make sure your first layer is solid. Otherwise, it could very much fail on you. And then you'll have a stringy mess.
But there's still not.
Nah.
Why not? How you gonna learn? Don't do.
I just wanna break your.
Learn by doing, guys.
It's super close. You do it very slow.
Yeah,
Yeah.
small increments.
It's also this way, right?
Yeah.
Yeah.
I changed this one a little bit more than, yeah, so.
That's too much. Do it like that. Like that.
Oh, I think it's close. I think it's good. You see that?
So that's probably because
Yes.
It's now it's two.
yeah. Also, don't inhale the fumes from that.
Kind of hard not to if you look.
Yeah, I've inhaled too much already too. Like I just get out, I guess. But yeah, it's a lot better. But yeah, so we'll see. The second layer will probably be like harder to tell. So that first layer is
Yeah,
what makes or breaks it. But yeah. So we have what, half an hour to print something else.
Just get the same thing but smaller.
Want to keep
Or the bow.
the but want
Oh, yeah.
a benchy? It's not gonna print
No.
because you gotta know like the limits, right? So the smallest thing is each wall has to be 0.4 millimeters thick. That's how thick the nozzle is.
Oh, it has to be the same size as the nozzle?
You'd prefer it to be like each wall to be at least a set of nozzle. That's why with a thinner nozzle, you can go like smaller or like more precise with like the resolution of the print.
So for mine, I have a 0.4 as well, but I do 0.1. Would that be?
The layer height, right?
Yeah.
That's fine. Layer height's fine. How about the wall thickness?
Okay. Yeah, I think that's awful.
should be 0.4 normally. Layer thickness can go as low as you want, I guess. But like the tallest it should go like your nozzle diameter. So any taller is like if you're your nozzle
You
is
switched it this way.
no, if you think about it, if this is the height of this layer, that's your nozzle. Like you see how each like water bottle like you can see each layer. You see each thing. Okay, fine. This like this having okay, when you see like each layer is gonna be like this, right? Anything bigger than this, now you don't have enough like material. So you have gaps now in your layers.
Yeah.
So you don't want a layer height taller than your actual. Yeah. Okay, so what do you want to print? Because I also have to hold this for 30 minutes. We take turns. Okay. Who's up? Oh, this is for an hour though.
Should we try something? Do you think it's more calibrated?
We'll see. Do you wanna try?
Yeah, let's try like another thing.
Okay. Now we'll see it show itself. Maybe you won't.
It's enough, right? Is it because you have to screw that in or what?
No, this is a catch on this. It's not working. So you see, yeah, something wrong. I think I removed pressure off of this. You see those lines?
Yeah.
It's not very good. So stop the print and then reheat the nozzle in bed, and we'll print something else.
We're just talking.
The red stop button. You hear a very different about you. So with this, don't click and take it off. Append it. Also, it's still kind of hot in there. Didn't even want to feel like this is. Wow. Now we can go with the trash can. I'm gonna get another part to print.
How do you read it?
So in the temperature,
Still not that.
yeah, so it's not fully heated yet. All right,
Is it mostly because of the tube or is it like space and more calibrated?
both
Beginning.
beginning was yes. It's in the temperature, heat comes in a minus and plus, and then minus and plus.
No, don't do that.
So all I did was, because I already have the heat. So every single time it finishes the Curry stop the thing, it turns the heater off, but it keeps the temperature on. So I just do is I press minus and plus to kind of reactivate the heater at the same temperature I wanted it to be. That's it. All right, what do you want to print? Small thing in 30 minutes. That'll probably take an hour. All righty. Thank you for coming. All right, what are we printing? Huh? A coin? I gotta find a coin now.
Yes, one.
Like a ring.
All right, we're gonna do a vase of was. Use vase mode. Using vase mode we do. All right, so what vase mode is, let's first talk about what vase mode is. It's in here. And layer, single outline corkscrew printing vase mode. It converts any file into a single outline, single wall, no infill file. So for bases, that's perfect. This is like a single wall that continuously files up. That's what it does. So if you were to do, let's say, huh? Yeah. Not barely. Yeah, well, pretty well actually, depending on your print.
You like squeeze it a little bit more like.
Okay, that will flex, yeah. But it should stay together if it's the right material. Let's say we have. I wonder if I have any pieces in here. I think I had a piece somewhere.
You might need to get a some water. You need to do a green, you have this water. No, it's like a person who can sit up for. I think he assumes everyone's done it, because this is a group class.
I haven't. Have you done it?
No, my grandma was doing for the projects.
Okay,
You could also use the Maker Studio. which is
Yeah.
still free. And that has trading on canvas, but a different component and trading once it's every week. So it's like
every week.
I think they got opposite. We check.
For the maker one or for
The Maker Studio.
okay, yeah, the maker one, I kind of know how to do.
All right.
Yeah. I don't know how to.
Yeah, and then there's like an in-person component where you go in and do stuff, but it's.
All right, so you see right here? This is a vase that's solid, right? In normal mode, well, what do you think the time will be to print it? It's just like this. Pretty tall. 17 hours to print, right? Well, you want a vase, right? So we go here, add the settings, go to layer, single outline with 0 top layers, 0 top layers. And then for the same size, we get 3 hours. But it's a vase. That. So if I were to scale this down to like 25%, right? Same settings. 37 minutes. It's each layer. So you can try doing that. I'm heading that one. And then okay. Do you want me to copy this one?
Here you. So
Yeah, hold the- 30 minutes and I'll hold this down. Close that. I'll take the first time. Print this. But watch yourself.
I feel like you do EPS, which probably isn't his biggest skill.
But the maker, I've seen for this.
I think it's all feeling.
Yeah, all billions of dollars. They're like tiny.
It's like you can do Tuesdays, through 4 to 5. And Thursdays.
Yeah, I don't know. It's like, I don't even know what's happening really for both of them. I don't know.
You know, also if you want just printed, if there's no link here to buy the truck. It'll do pictorial. Like,
Oh, like on the internet?
no, like find other people on campus who
Oh,
have
yeah,
their
yeah.
printers and like
Sure.
get prints from them.
That's true. And it'd be zero cost. They'll put it in the budget. Yes.
I'm sure you can ask Yash.
Josh,
Mhm.
how do you print on campus aside from Maker Studio?
There is the maker, like
The
the
engineering.
iLab.
No, that's all under Sil.
Huh?
That's all under Sil.
That's the row?
Sil.
Which is like the people who do the makers.
Oh.
No, I meant.
You want-
asking who wants to print for you.
Oh, okay. Would you possibly want to print some parts for, what's it called, a measurement slab?
How big is the part?
Huh?
How big is the part?
Probably like maybe less than a foot. Maybe
Less than a foot?
8 inches for a mount or something.
How much do you charge for that?
Yeah.
Yeah, you know.
So right now, my parents are kind of, as you can see, both of them. So we're paying it fixed.
Oh, like.
How big it is for you?
You
What do you need to buy?
slippery.
I don't
Try
print
some-
sometimes.
I don't want
It's fine, I'll see.
I don't
Like
think,
what it
yeah.
is.
We don't even know what design we're gonna come up with.
It's a rocket science, just trying to figure out where to get this stuff. Like I know, like my number has a printer. Best hand.
I share the printer, but good use printer, that's
Yeah.
but I can pass them if you want.
I can try and do stuff for you, but my printer, like, I just haven't used it very much, so I'm
So
just gonna do it.
descriptive, like this is level.
Okay, take big stuff. That's my goal. It's got a really nice.
It's Yash.
Yeah.
So is the outside rings the base?
That's the brim, so, or, skirt, right, skirt. Yeah, so he's not putting the
Okay.
front part.
I got it.
How small would the part be
No,
for a brim?
Is it a control spot?
Like,
I'd say if you're gonna do it, like, right now, according to the, think about the entire thing,
Yeah, it has a really nice-
a lot of math is on top. Small cost over the entire thing, put a brim on it, because you want to give enough leverage to
Yeah.
from like, let's shake things happening.
what if it was like a filler, so it's like the same throughout?
Think throughout, how long is it?
Well, oh yeah, that would.
So that'll change, if it's extra long here,
Oh, for different
you
walls.
wanna put this in.
Let's say it was half the diameter.
yeah.
base, But
I should have
like this. Wow.
You put on the river.
Yeah, yeah.
It looks like, it might fall over,
I'm not doing anything.
like for this, I want to put a brim on it, even if like this, because small cross section covers the entire mass.
What's the difference between the brims?
So skirt, you see right here? So it's a gap on there, right? Small gap. So brim is the same as a skirt, but has a
Done.
so the part first layer, so long part.
So what's
Right.
the benefit of?
So I'll see you.
So
Tuesday.
skirt is there to help you like fine tune your calibration. Thank you. To kind of fine tune it, and then also to just like, make sure to filament in your actual.
Okay.
Oh, thank you, Bethany. I completely forgot it always.
Bro, following this.
Are you?
It'd be fun. Shouldn't if you have.
Sorry, it's not personal. You're not.
I have a fan that like connects on the top like this and then like blows into it.
Yeah,
But does that stop the emission?
no, that's like my part pan, my pan out here, the second pan right there, the white piece underneath it. It blows air onto the actual
Just to
grid.
cool it down, right?
Just
So it
cool
doesn't
it.
stop the emissions.
No, it helps it blow.
Yeah, okay.
If you wanted to set the emissions, you would really need like a case over it with like a filter.
Oh, like the one in the room, like that one.
That one doesn't have filter on it.
Oh, it just has a case.
Yeah, but at least it keeps everything within itself, and they open the door and like, oh my god.
Yeah.
And
I've also, like, I've seen, the SLA printers, so like built-in carbon filter now.
probably good. We should have something.
You can try and get like an extra carbon filter. to put in there.
Should they have 3D printers at?
Huh?
Yeah.
Yeah. You wanna get some, this is like, what, 200 bucks? You
Yeah,
get-
cool to get started, but I want to. But I know they have it.
Yeah. And then this one from CAD, you can make anything you want. Oh, once you learn from CAD, so then you know how, then you'll know basically, once you 3D print, you know how to CAD, you know how to design products, but you'll know specifically what is 3D printable, what's manufacturable with the 3D printing. Then you can design it for that one, and then that part. So you can get projects. So since this is a small print, so your size also changes how fast your print can be and the details, right? So a small print like this, you see the print really slow. A bigger print would give it a larger temperature to accelerate fully. You know, a faster print. You might have to have a faster one than this. But it depends. When we're starting, I thought right here. You got the idea of it.
Yeah.
Yeah, that's
Mine,
big.
mine I have at like 200, I think, or something.
And mine can't do that. That's not.
Mhm.
Yeah. I see it.
Can I take it off?
Yeah. So be careful because it's so hot. It's still like, you know, it's feeling. Even the first layer. It's like, see, all of mine is connected. Even because the first layer is kind of thicker, but it's still like one flesh, like, you see that, right?
We can see like the individual,
But
but
you'll
like,
see it's
it's
connected together.
connected.
Yeah, because the first layer is like a lot bigger than the actual. So I have like 0.6 millimeters wall thickness in the first layer, just to make sure it's stuck on. That's one.
Like a piece of stuff.
So yeah, that's 3D printing. That's cool. Thank you guys for coming. I'm gonna stop the print. Okay. I hate how I've